Hello and welcome to our observation of the 10th anniversary of human life, work, and research aboard the International Space Station. I'm Kelly Humphreys with the Johnson Space Center's Communications and Public Affairs Office, and I want to welcome you here today. These activities are part of a series of a larger NASA series of events that have been going on and already started today. Include similar roundtable productions going on at Kennedy Space Center and Marshall Space Flight Center and NASA headquarters. Today's activities here at Johnson Space Center are part of a joint effort between the Public Affairs and Communications Office and the JSC Chief Knowledge Officer and their storytelling series that aims to document for posterity the knowledge behind our nation's human space program. And you saw earlier today Joe Kerwin's discussion from last week about the development of space stations in general. Introducing today's panel is Milt Heflin, the Johnson Space Center's Associate Director for Technical Matters. Milt joined NASA in 1966 and was a lead recovery engineer for the splashdowns of the Apollo 16, Apollo 17, Skylab 2, 3, and 4 missions, and the Apollo-Soyuz missions. He was a mission control flight director for 20 space shuttle missions and served as the chief of the flight director office and deputy director of the mission operations directorate. And Milt will be introducing our panel today, and I'll hand it over to you.
Thanks, Kelly. Before I introduce the panel, I want to take a couple of minutes and just give you a personal perspective of where I believe we are today. When we landed on the moon for the first time in 1969, I had been working here for just about 3 years. So my perspective back then and my perspective today is certainly different. And one of the things I've tried to do is sort of look at and gauge the degree of difficulty from landing on the moon for the first time and what we have been doing the last several years here with the International Space Station. Now, from my very non-scientific study, I have come to these conclusions. From a purely technical and physics standpoint, I consider them to be about the same degree of difficulty. However, from an overall programmatic, social, and political arena standpoint, I think building ISS has been much more difficult. And all of you involved need to really appreciate what you have accomplished. And I think what has contributed the most to making this harder has been the long-term persistence and dedication expended by us and our international partners to make this thing work. Bringing together not only different people cultures, but also different space flight cultures. And as hard as it's been, you all have made it look easy. And you've done that by staying hungry, and you take no detail for granted. So keep up that vigilance. It's very important. And as Chris Kraft remarked a few years back addressing a group of engineers at MIT, every day is a compromise. So I believe one of the major legacies from the ISS program will be this international connection we have established, one of the foundations we must build upon for future human exploration beyond lower Earth orbit. And finally, to get off my soapbox and introduce the panel, in talking about groups of people, I often refer to ISS as a zero-gravity United Nations. And I tell them that I don't think it does work a lot better than the United Nations that is hosted in New York City. So congratulations to all who have contributed to this program since its beginning. Please keep that up. And now introducing the panel. First of all, I'd like to just a quick summary of where we've been. The first element for ISS, the Zarya module, was launched from the Baikonur Cosmodrome in Kazakhstan in November of 1998. The first American module, Unity, launched aboard Space Shuttle Endeavour in December of that year, and the first crew, Commander Bill Shepard, flight engineers Sergei, Krikalev, and Yuri Gidzenko, launched on October the 31st, 2000, and entered the fledgling outpost on November the 2nd, 2000. Since then, 196 people have visited the station as it has traveled some 1.5 billion miles in orbit around the Earth. And by another perspective provided to me, that's enough for 8 round trips to our sun. So, today's panel, in the middle of the group here, Mike Suffredini. Mike has been the International Space Station's program manager since 2005. He's responsible for the overall management, development, integration, and operation of the station, and he looks to a talented worldwide team to accomplish that. He works with the leaders of NASA's 4 partner agencies, the Canadian Space Agency, the European Space Agency, the Japan Aerospace Exploration Agency, and the Russian Federal Space Agency on both strategic and day-to-day management of the international program that involves 15 sovereign nations. Mike has a very diverse skill set for making him very effective in this arena. Mike was deputy manager of the program in 2004 and 5. Prior to that, he was operations integration manager and chairman of the station's mission management team from 2001 to 2004, and manager of space station vehicle development from 1999 to 2001. And manager of station's payloads office from 96 to 99. So, as you can see, a great deal of expertise and experience in the station program. Prior to that, he came to the station program after serving as assistant manager for the Space Shuttle program from 1995 to 1996. Next, I want to introduce, just to Mike's left there, is Peggy Whitson. Peggy has been chief of the astronaut office here at the Johnson Space Center since 2009. Prior to that, she was a flight engineer and science officer on Expedition 5, accumulating more than 184 days in space. She followed that by serving as the first female station commander during Expedition 16, spending another 192 days in space for a total of 376 days, so many hours and so many minutes. Both of her missions were long-duration missions aboard the space station, helping her set the woman's world record for the most time in space. Peggy also holds the woman's record for spacewalks, having performed 6 EVAs for a total of 39 hours and 46 minutes. Peggy began her career with the agency before becoming an astronaut. From 1989 to 1993, she worked as a research biochemist in biomedical operations and research branch here at JSC. She performed numerous roles before joining the Astronaut Corps in 1996. My soundbite for Peggy is recognizing her enormous reservoir of energy that always is focused on team accomplishments. And on the end of the road down here on your far right is Mike Lopez-Alegria, or L.A., or Mike L.A., as we refer to him. He's a retired captain in the U.S. Navy and assistant director for Space Station Flight Crew Operations. L.A. joined NASA in '92 and has flown 4 space shuttle missions, his last one as the commander of Expedition 14, a 7-month mission to operate, maintain, build, and use the station and its research facilities. A veteran of 4 space flights, L.A. has logged more than 257 days in space and performed 10 spacewalks, totaling 67 hours and 40 minutes. 2 of his shuttle missions helped with the building and construction of the space station. STS-92 delivered the Z-1 truss and pressurized mating adapter 3, and STS-113 delivered the Expedition 6 crew and returned the Expedition 5 crew to Earth. As I observe Mike L.A. in action, I take great comfort in his understanding and assessments of any technical, operational, or safety issues associated with this worldwide partnership. And right next to Mike is Clay Anderson. Clay is also a NASA astronaut and space station veteran. Clay's first mission was a long-duration mission as a flight engineer and ISS science officer on Expedition 15. He launched to the station on board Shuttle Atlantis with the crew of STS-117. During his 152-day tour of duty aboard ISS, he performed 3 spacewalks, totaling just over 18 hours. In addition, Clay operated the station's robotic arm, Canadarm2, to move the station's pressurized mating adapter 3 to the Earth-facing port on Unity in preparation for the delivery of Harmony by the crew of STS-120. Clay returned home aboard Discovery as a member of the STS-120 crew. Clay also flew as a mission specialist on 131. a resupply mission to the station, performing another 3 spacewalks. So Clay has a long history with the agency. Before becoming an astronaut, he joined NASA in 1983 in the Mission Planning and Analysis Division, and later moved to Mission Operations Directorate and was selected as a mission specialist in 1998. Now, I certainly enjoyed my time in MOD with Clay and was pleased when he was selected to be an astronaut. His focus and attention to details have served the cause well, and keep smiling, Clay. Thanks. John McCullough, just to the right of Mike Serfadini. John McCullough is Chief of NASA's Flight Director Office. He has led more than 620 shifts as a Flight Director in Mission Control. John was the lead Flight Director for Expedition 7 and the STS-115-12A assembly mission with Atlantis in September of 2006. He also managed the build-up of the new Space Station Flight Control Room, FICR-1, which began use in September 2006 and is the current home of the Space Station Flight Control Team. Prior to his current job, John established and served as Chief of the Spaceflight Training Management Office, responsible for all crew and flight controller training. From 1992 to 2000, he supported 14 shuttle missions as Mission Control Payloads Officer. Additionally, he was the NASA IMAX Mission Manager for the Space Station assembly flights. That was responsible for getting all the hardware manifested, flown, and used on orbit. I greatly appreciate John's leadership, mission operations, as they have navigated and adjusted to the environment, always managing to keep the technical in mind. And that has become somewhat more difficult because quite often today it ain't about physics, it's about politics. John Vollmer is Director of Avionics and Software for the International Space Station, just to Kelly's left here. He's a Director for Avionics Software for the International Space Station and Space Exploration for the Boeing Company, which is NASA's prime contractor for Space Station. He leads Boeing sustaining engineering for Space Station communication and tracking, guidance, navigation and control, command and data handling, avionics and software systems engineering, and all aspects of software, including flight, ground, test, and simulation. Do you ever sleep? Yeah. His organization also supports NASA with maintenance and operations of the various laboratories required for on-orbit operations, for simulations, for troubleshooting, and test and verification activities for all the interfacing entities. Prior to his position in avionics and software, John was Director of Program Integration for the station. He controlled cost, schedule, and technical baselines for Boeing's station contract, and served as the primary interface with NASA for contract changes and strategic program decisions. Over the years, I have watched John and his contractor team in various technical interchange meetings exercise enormous patience and professional persistence in negotiating with international engineering teams to get what was needed so they could move on to the next challenge. And many challenges they have indeed overcome during this past many years. Let's see, Kelly, do we have time now for the panel, or have I used up all the time?
I think we're good. Thank you very much,
with that,
Mel.
it's yours now, Kelly. Thank you.
All right, thanks. And I want to start today's activities off by letting Mike Sefardini get the first word in on this significant milestone in human spaceflight, something that I know he's personally put his heart and soul into.
Well, good morning. Guess I'm the lucky person that gets to get things started. You know, when you think about where we've all been together, you try to think of the right adjectives to describe what we've been through and what's on orbit today. And we can talk about the size of the spacecraft. It's very, very large, 150,000-pound spacecraft. It's got upwards of 32,000 square feet of internal volume, 4 million lines of code. The list goes on and on and on. And it's an amazing spacecraft, and the feat that we have accomplished as a team with our international partners is honestly nothing short of perhaps the most difficult thing ever attempted by humankind. So it's humbling to sit here in front of you today and in front of the audience and to reflect on what's occurred over the last 10 years, actually over the last 12 years, since the first flight, but of course today we're focusing on the fact that we've had 10 years of permanent human presence as of early next week. And another interesting tidbits, and we're full of milestones in this program, which it makes it fun, because you know, if you didn't have milestones every so often, you turn around and say, what did I do yesterday? But Monday I walked into the FRR and was stopped by Kyle Herring, who reminded me that this was 3,644 days. And I said, thanks, Kyle, that's interesting. And then Kyle told me that was the previous record for continuous human presence on space. So not only are we approaching 10 years on ISS, but we now are the record holder for permanent human presence in space. And that's a neat tribute, but if you think about it in terms of the international partnership, which to many of us, and I'm included in that group, believe that is perhaps the more remarkable thing about International Space Station, is the partnership and what we have done together as a partnership. But since we really began this as part of the Mir program, with the Shuttle Mir program, our presence as an international community in space is much, much longer than the 10 years we're here to celebrate today. And that is extremely important. We learned quite a bit in what we referred to as the Phase 1 program that helped us be successful in ISS, and we ought to think about that in those terms. The International Space Station program and the partnership, to me, not only is this space station, this remarkable vehicle that's on orbit today, in my mind, the toehold and our ability to do exploration in terms of not only human research but technology development, but also in terms of the partnership that I believe is necessary for us to do exploration. And so while we sit here today and reflect on the many years we've all spent together building this space station with our international partners, we should believe and think about the fact that we will explore, humanity will explore beyond low Earth orbit, and this really was the first step in that endeavor. And so I look forward to reflecting on this remarkable journey with everyone today, and so I'll turn it over to Kelly and he can help us do that.
Thanks, Mike. Just a little bit about the format. I'm going to kick things off with some questions to start discussion among the panel, and then we'll have time for employee and media questions if we have any toward the end of the hour. So let me start it off with the first question, which is kind of mandatory for everybody, and that is, how did each of you first become involved in the International Space Station, and how has your role evolved since that point? And why don't we just start with John here, since he's handy on my left, and work our way down.
Okay, well, thank you. And I actually got involved in space before Space Station. I started working on the shuttle, on the solid rocket boosters for Rockwell at the Marshall Space Flight Center back before the Challenger disaster. So I got involved in space then. I grew up around space. My father was on the Apollo program, and when Station came along, well, that was the next big Apollo for me, and so I wanted to be a part of it. So I joined the Boeing company. They were bidding on at that time, the Work Package 1 phase of the program. So I joined the Boeing company and helped them get through the proposal phase of it. I started off building specifications for the laboratory and the pressurized elements, and that led into working some design team activities where we went through and looked at optimization of the station subsystems. That ended up leading to the Crystal City redesign effort when the president asked us to go work with the Russians, and so I participated in that. And that eventually led me here to Houston to establish the first contractor team to work with NASA on establishing the new, at that time called Alpha Station. Since then, I've had various responsibilities. I became the Node 1 launch package manager, and so I was participated in getting the first U.S. element up there, and it was an exciting time when we integrated it with the Zarya module from Russia and really formed that first core station. And since then, I've gone on and worked payloads and utilization of the station with payloads, and then program integration, various system engineering, and now working avionics and software. So I've touched a lot of the the station program and have an understanding of a great deal of what's gone on over the past 20 years.
Okay, thanks, John. John?
Well, let me say I'm honored to be here and represent in some small way the tremendous team that is behind this milestone and working today and has been working up to this point and into the future on the operations and the training and the preparation for a space station. As Milt mentioned, I started out on the shuttle side in flight control, grew up with the shuttle as a payload officer, and that position evolved into assembly checkout officer, and the assembly checkout officer is the one responsible for integrating the hardware with the mission objectives and getting them up on station, on orbit. I worked 3A, which is one of the early flights. Got to work with a lot of the folks on this panel repeatedly in close quarters, and it's a great team, awesome group. And my jobs have evolved over time through the training community and through the operations community as a flight controller, flight director, and manager. Largely in the last 3 years, I've been associated with every flight at the MOD console, the liaison between the flight control team and the management team for every flight for the last 3 years. And to see the consistency and the dedication and the effort that every team puts into accomplishing the goals that they do is really an honor, and really sets your mind at ease for the future, because we're in good hands, we have a good team. And so that's really about it.
Okay. Back to you, Mike.
Oh, well, let's see. I was happy working as the assistant manager in the Space Shuttle program for Tommy Holloway at the time. I had been working for Brewster, and then they changed out management, and I was working for Tommy. So it was quite a pleasure and a learning experience to work with both of those gentlemen. And I think I was about a year and change into it when Harvey Hartman came and visited me one day, and you guys probably remember him. He was the head of human resources. And he said, hey, George thinks you need to go work in the budget office at ISS. And I looked at him and felt like saying, is this a joke? But Harvey's a nice guy, but generally didn't come to your office to joke about things like that. So I said, well, that's interesting. Why the budget office and why space station? And he said, well, I don't know. George just thinks that's a good idea. And he suggested that you go interview with Dan Tam, which many of you will recall was our budget king at the time. And he was like a one-man show relative to deciding what we should invest in and how much it would cost. And so I said, okay, well, I'll go interview. That's fair enough. So I went to sit down and talk to Dan Tam, and I said, Dan, what are you looking for? And he says, well, I'm looking for a lawyer with a CPA degree. And I said, oh, okay. So why are you talking to me? And he said, well, George said you should come over here and talk. So so we talked for a little while, and it was an interesting conversation. And then I left there really concerned that the budget guy wants a lawyer with a CPA degree, and you know, I knew how to do engineering and I could follow numbers, but I didn't. The lawyer and CPA thing kind of scared me. So I went to Harv and I said, "Say Harv, you know, what would happen if I said I really didn't want to do this?" He goes, "Well, Mike, you know, I don't think it's ever been done before. I'm not sure I'd do that." So I became the deputy manager of the budget office, and since then have kind of grown up in the space station program in many of the offices, and find myself where I am today. But it's been a fun ride, and I look back on it now and thank George for giving me the opportunity, because it's been a remarkable ride.
Just before we go over to Peggy, just because you didn't mention his last name, you're talking about former JSC Director George Abbey.
Oh,
so just so everybody knows.
So
Peggy.
we all grew up together, right? And so you say George, there's no other there's probably thousands of other Georges out there going, "What are they talking about me?" But Mr. Abbey knows who we're talking about. That's also important.
Well, I've always said that I've never wanted to do anything besides work at NASA. After seeing Neil Armstrong and Buzz Aldrin walk on the moon, I thought, wow, cool job. I'd like to work there too. And I think it was actually kind of key timing that the year I graduated from high school is also the year they picked first female astronauts. And being from, you know, rural Iowa on a farm, you don't know a whole lot about the process. And I was just like, okay, well, I'll do that too. Luckily, I had no idea how hard it'd be. And as soon as I finished graduate school, I started working at NASA for a contractor, initially as a NRC postdoc. postdoctoral fellow, and then as a contractor, and eventually for NASA. And in that 10 years before I was lucky enough to get selected and I was working at NASA, I felt like, I always wanted to be an astronaut, but at the same time, I think having had that experience at NASA really made me a much better astronaut, because primarily my jobs involved working with the Russians. Initially as an investigator on a one-on-one level, then as a project scientist, and then later as a science working group co-chair. So all of those relationships that I built, I think, were a key part of eventually being selected as an astronaut. In those roles, I think I learned a lot about working with international partners. I think that obviously is very important in the International Space Station, as everyone can attest. There's good days and there's bad days, but it's all been a really good learning experience. Some of those days you wouldn't necessarily choose to relive, but it's all been valuable, and it helped to get the station to where it is now, and it's such a beautiful place. My first space flight, I was so impressed with just being in space and living in space and looking at the view of the Earth. And my second space flight, I got the opportunity to do even more spacewalks, and I was really, really impressed with this structure, this huge structure that we've built there.
Thanks, Peggy.
It's great to be here. I'm very excited, especially to have you folks out in the audience. I started here, I was talking to LA earlier, that way back in June of '81, I sat in the chairs here in this auditorium as I listened to the post-STS-1 symposium that was being held here. And I was a summer intern at the time for NASA at the Johnson Space Center. So I grew up here, as Mike has referred to, and I also had the opportunity, though, to go from sitting in those seats to be able to be fortunate enough to sit in a seat like this today. When I was an early engineer here, we worked on the shuttle and until the point where this thing called a space station was being talked about. And everybody said, oh, we need people to go work on that. So somebody just came to our desk one day and said, hey, you're now working on station. And it was a great time because there was no space station. There were just designs of space stations, different kinds that had different features. One shaped like a triangle, one shaped like a huge keel in the middle of space, and others shaped like you might see on the TV movies with all the modules locked together in different shapes. So it was really cool for me to be able to have that opportunity to begin in the design of this structure that then I had the awesome fortune to live on for 5 months. So for me to come from being just an employee that had a dream to work on whatever it was NASA had in mind, and then to be able to live on that structure that with all the people out here I helped design it was quite an achievement for me. So thank you to all of you for giving me that opportunity.
For my part, first, Kelly, thanks for including me on this. It's obviously a privilege to sit up here, but it's also very entertaining to hear some of these stories that I hadn't heard about. And unlike some of my predecessors, I did not grow up here, although having been here since 1992 now, I've lived here longer than any place in my life, which is not unusual for a military guy. But my path to NASA was pretty typical for a military astronaut through a test pilot school, and then directly here in 1992. My start with the ISS program was in about 14 years ago, so at the end of 1996, I was assigned to be the Director of Operations Russia, which sounds like the czar, but it was really the head of an office of about a dozen people. Half of them are Russians, half of them are NASA contractors or civil servants. And our job was sort of the care and feeding of astronauts that were participating in the Shuttle Mir program, or as Mike referred to it before, Phase 1. So we had about 4 or 5 people living out there. And not long after that, the first crew, Bill Shepard and his backup, showed up for the beginning of ISS training. So that was October 15th, 1996. I stayed there for 9 months, learned a lot. As Peggy said, you really do get a lot of benefit from interfacing with the international partners. As a result of that experience, I became involved with something which was at that time called the Bilateral Crew Operations Panel. Now it's the Multilateral Crew Operations Panel, and we decide, among other things, what astronauts, cosmonauts are going to fly on which increments, who's a commander, and that sort of thing, which has been interesting the whole time. A whole new set of challenges, like somebody before said. It's a lot less about physics than it is about politics sometimes, but that's not bad. That's just the world in which we live. I also was lucky enough to visit the space station twice. The first time, nobody was living up there. In fact, we closed the hatch on the unmanned space station for the last time. That was on October 21st or so, 2000, and about a week later, Bill Shepard and his crew showed up and opened that same hatch and came in. Actually, they probably came in a different hatch. And then again, a little bit later, we brought up the Expedition 6 crew and brought Peggy and her Expedition 5 crew home. And we also brought up the P-1 truss, which was the second beginning, if you will, of the long traverse structure that now holds the solar arrays, radiators, et cetera. And now it's sadly wearing a tie instead of a flight suit more often than not, but I guess I can't complain. I have an interesting function where it's all operations-based, kind of take care of this sort of care and feeding again, but not of people that are training in Russia, but people that are training all over the world and flying on the space station.
Okay, well, thanks, everybody. Let's start off the discussions here with the first question, which is, what, in your opinion, is the most significant accomplishment of the International Space Station team? And I just ask you to jump in as you feel appropriate and have a good discussion.
Well, pretty much everybody has said the international partnership is probably the most significant accomplishment. Not only is it the politics, but to be able to understand each other well enough to be able to put together pieces of hardware that we didn't actually put together on the ground. Putting it together up on orbit was pretty special.
I think the interesting part about space station is the most impressive accomplishment is probably the next one. Whatever it is, it's always the next one. If you work with Mike or anyone around here very long, it's what's the next thing that's going to happen, and how can we put that together and achieve it. But I think, like Peggy mentioned, the space station's I think crowning glory is that it's made the world a smaller place, both from a perspective of international cooperation and technology, and really to give people something to think about as we push the frontier out. I think those are significant milestones.
I want to cast my vote for the international piece of it as well, and with a little bit of a story. You know, as I mentioned before, I grew up in the military, and as I was starting my training as a junior officer, the Russians were the bad guys. I mean, there's no doubt about that. And I learned a lot about the way they fight wars and the way they man their aircraft and their ships. And I never dreamed that, you know, some 20 years later, I actually wore my U.S. Navy uniform in Red Square and laid flowers at Yuri Gagarin's grave there at the Kremlin. So I think that speaks volumes. If we can continue what Mike said, to be sort of the United Nations in zero G, I think that's a wonderful achievement.
You know, the partnership is clearly the answer to that question for me, but I will touch a little bit on what Peggy briefly talked about. In order to build a spacecraft the size of ISS, it had to be assembled in low Earth orbit. But when you take a few moments to realize that those elements were built, many of them here, many of them in other countries, and not one, not even the ones here, saw each other before they got to orbit, and you reflect on the very small problems that we occasionally dealt with during assembly of ISS, that is awe-inspiring. That's just a monumental feat, and it speaks volumes of what the engineers were able to do. And in a previous, the KSC did a similar thing on TV the previous hour, and David Bethay said it very well. There's nothing like getting an engineering drawing, and you can get a good engineering drawing from any engineer in the world, and another engineer can pick up that drawing and work with it. And I'm convinced that's true based on the success we had with Space Station.
You know, I think it's interesting that, you know, one of the things that I saw in Freedom was the constant, you know, keeping the budget going every year. And so it's amazing that this project has plowed through all these years, and we've been through several administrations, not only internally here in the U.S., but several administrations in other countries as well. So it really bodes for how we as a unity of nations pull together to make this thing happen. So once again, the international partner aspect of this thing is incredible.
I guess we all have to answer, or we lose points at the end when they total up the score. So the one thing I would add to all this is what the space station does for the world, as kids all around the world and adults look up into the sky and see that thing pass overhead. I think that the other thing it does, beside all the wonderful ideas of the international cooperation, is it gives people something to look up to and something to dream about, which, we don't know what the next spectacular activity is going to be, but maybe they do.
Okay, thanks. The next question, I'm going to change up just a little bit because we've had a really good discussion on the international cooperation aspect. So I'm going to ask you, what was the most important large-scale technical challenge of the first decade?
I think if you ask any flight director or flight controller or engineer associated with Space Station, they'd all give you a different answer, probably because they were all involved in very, very important aspects that each one had to be successful with. We've installed huge pressurized modules and large truss components, powered arrays, huge choreography between spacewalks and robotics and ground commanding. Every month we send 70,000 commands to the space station from the ground. So it's a very intensive, focused effort that everybody has their heart and soul poured into. I think you'd get a different answer for each person as to what installation or repair or significant activity really has made the difference for Space Station. They all have had to be successful.
I'd like to chime in and say I absolutely agree. I think everybody has touched a different part of this elephant, and we see a different piece of it and saw the different challenges associated with each piece.
I think the assembly is the big thing, and I touched on that earlier, but as we get close to this milestone and others, it causes me to reflect. I'll tell one short story, and it kind of speaks to the team effort to make all these flights work. We were rolling out the P6 truss, which was the 4A launch, and our Boeing friends came to us, and we were right about to roll out, and they came to us and said, based on testing, DCSUs, which are DC switching units of some sort, very large boxes, 2 of which resided on P6. We had a component that was faulty, and they were concerned that it wouldn't survive very long in orbit. And after many hours of talking about that, we were finally convinced that perhaps this test data was true, and that in fact we were at risk on this element. Except one of the things that we had really tried to pride ourselves was to, once we started down this path of flying these flights, we were trying really hard to make sure we had the elements ready when the shuttle was ready to fly. Fortunately, the shuttle was nice enough to give us a little margin every so often. We were able to slip underneath of it. But in this particular case, we were literally about to roll out, and so we had to figure out as a team what the right answer was to solve this problem. We're going to put it back in the queues and remove these boxes and change them out and do all the testing. Or we were going to try to fly as is, or were there other answers? And the Boeing guys, led by at the time Greg Martin, who was my counterpart in the vehicle office, came back with a really clever idea. And their clever idea was they were going to move the top from the box while resided in place, change out these, I believe they were large capacitors at the time, replace the capacitors, put the lids back on the box. There was some testing we could do right there in place, and we did that on that vehicle. And delivered that vehicle to the pad in time for the shuttle launch. And that was one of many stories that we could tell, but it speaks volumes to the amount of work that the team did and the kind of effort that took place regardless of time of year and time of day, that everybody was willing to step in there, and they always worked to creative solutions and as a team effort, solved many, many problems that allow us to be where we are. Again, the assembly looked easy, but there was a lot of work by a lot of folks to give us the success we've had on orbit.
Okay.
I think as a system engineer, the most important thing we did, of course, was system engineering. So it was a real challenge. We did some cutting edge system engineering on this program. Everybody, we talk about the space station. I talked about as the Node 1 manager, we put the node was area and we formed the initial space station, the core. But really what we've done from a system engineering standpoint is we've built not one, but literally hundreds of stations, and we've done it incrementally on orbit. So our factory's up there on orbit, and like Mike said, these things have come apart from different parts of the world. They never saw each other on the ground. Anyway, the system engineering part of pulling that together and specifying that design to make it work when we actually built the hardware was a challenge that we overcame, that we absolutely had to overcome to be successful. So different perspectives.
People don't appreciate that. In the outside world, I haven't ever found anyone who really appreciates that every single flight, every single step in the assembly, that vehicle had to survive for a very long time. So we had to assess every configuration and ensure that configuration could live on orbit for an extended period of time, because we could never be sure when the next flight flew. And in fact, as a result of the Columbia accident, that paid huge dividends, because we stayed in that particular configuration that I think LA left it in his flight. And it spoke to the amount of systems engineering work that had to be done, because that was some of the most trying things we had to do, I remember, at least as a vehicle guy, is each of those stages and thinking about the long term. And what you wanted to say is, gosh, the next vehicle is going to be there in a couple months. It'll be okay. But that couldn't be the tact you took. You had to say long term, this configuration could survive. And that was one of the most challenging aspects of building a vehicle of this size. So I agree with you.
Yeah, we really did. We specified it end to end, and then you had to chop it into pieces that were launchable and make sure each of those had their own mission and represented an independent space station.
Well, and you haven't finished it yet. It's still not going through changes. You're going to send up another module that wasn't originally planned on the next shuttle mission.
Yeah. The crew, every time we flew an MPLM, the crew would say, and we'd really like to keep it on orbit. And we'd say, we really can't afford to keep it on orbit. But now we're doing that, so.
Thanks.
Yeah, it's present.
Let's move on to the next one, which is what little things build into bigger things, and vice versa. What's the most important small-scale challenge of the first decade that we've had to overcome?
I don't know how you define what's big scale and what's small scale, because like you said, the small things end up adding up. But something I think gets overlooked, and every time we do, it kind of turns around and bites us, is the environment up there. So we've kind of belittled the physics and said politics is important, but let's not forget the physics. I mean, it can get really cold and really hot out there, and all these connections, whether they be fluid connections or data connections or electrical connections or physical mating of these surfaces, have to take into account the variation from day to night. We relatively recently discovered this problem with launch run shadowing, which really takes a lot of management on John's team's part to think about what are we going to do when we're maneuvering. We have a vehicle arriving or departing. How does that affect the whole go, no-go process? So a lot of the things that are due to the fact that, oh, by the way, we're in space, are pretty important.
I think managing the living and breathing aspects of a day-to-day operations with a changing vehicle has been touched on significantly. But I think, the software updates that have to be done on the ground in the control center and on the vehicle to keep everything in sync as you change the configuration, the ability to live in the house that you're changing as you change it these things are very complicated and have to be right every time. And so those little challenges are things that add up over time to success.
When I was on station with Oleg Kotov and Fyodor Yurchikhin, partway through our mission, I remember being in the lab one day and just working at the computer or whatever it was I was doing, and Oleg floats down and he looks at me, and with a smile on his face, he says, "Asu не работает." And I looked at him, and that means the toilet's broken. And right after that, he said that we can't eat anymore. And you know, when a guy when you only have one toilet and it's in the Russian segment, and the Russian guy comes and tells you it's broken and you can't eat anymore, it kind of, as you live in your day-to-day house, it kind of makes you a little nervous. So it built up a little bit in that it kept breaking for several days, and we were one of the first crews, I think, that had to deal with multiple toilet problems over time. But that fortunately led to getting the toilet fixed. We now have 2 toilets on board. Everything works better. We're actually doing some amazing things in terms of regenerating waste fluids and things to allow the crew to have more water. So all that stuff, you know, as you build up over time, little things in the life inside the tin can up there can lead to some great things in the end. So.
Okay. Well, it's the next question, a little bit more expansive, and that's what's your biggest hope for the next decade of the station?
Mine, of course, is, and I say it every chance I get, is that we fully utilize this vehicle that we've built, and we're not quite there yet today. We keep the crew very busy, but if you look at the projections for the research on board ISS here in the near future, it looks like we're going to have some available capacity. And then if you look at the curve, it looks like it picks back up. But I'd like to see us fully utilize this vehicle and get the most out of her, as well as make sure it is fully utilized to get all the information and test data and that we need to do exploration, because we're going to try really hard to get somewhere in the neighborhood of 30 years out of this wonderful vehicle that we have, and in that time we've got to figure out how to cross all the challenges of long duration space flight, and this is the way for us to do this. The transit to Mars has many challenges. The long-term transit period has many challenges, many of which we can test and mitigate on board ISS and prove to ourselves we know how to do that. And I think regenerative eclipse is one of those systems today. We're learning a lot about on board ISS, and crew health has been a major step. We've got the ARED on board ISS. It seems to be working very well. Our crews are coming home in really wonderful shape, but we can't fly an ARED on some sort of transfer vehicle. That thing's probably as heavy as almost all the other systems combined that they plan to carry. So we have to figure out ways to make the system smaller and still be able to do the same mitigations that they do for us on ISS today. So we have a lot to do between now and exploration, and I think my hope is that we fully utilize ISS to give us the experience and the information we need to be successful when we leave low Earth orbit.
I'm going to jump in real quick. ARED, for those who are uninitiated, is the Advanced Resistive Exercise Device. Basically lets you work out like you're working out on weights in the absence of gravity.
See, I see all these folks, and I know I
These
don't have
guys
to say
all know,
that,
but the folks on TV
and I
might
forget
not.
that I got
So, Kelly, I guess on a more philosophical basis, I'd really like to see the station represent an inspiration to the next generation, just as Apollo did for my generation, and as Peggy reflected as well, right? So I hope it encourages the next generation of scientists and engineers and gets them interested in space and helps us carry on the tradition of space exploration. So.
And following up on that, I think we have a couple of challenges facing us. First of all, as the shuttle is retired, it's really a magnificent, one of a kind, unbelievably sophisticated flying machine, and when you see a picture of it or a silhouette of it, it sort of says something. It's very symbolic. And as it is retired, I hope that we can continue to be able to inspire, as was said, because I think that the day-to-day operations on the space station to the uninitiated don't seem as exciting as a shuttle launch or landing or some of the operations that are so high visibility that go on during a shuttle mission. The second thing that faces us is, we live in a society where we have ever decreasing satisfactory times for return on investment. So it used to be you'd write a letter to your relative overseas and it would take a month for you to get an answer. Now you send an email, and if you don't get something that same day, you're impatient. What's going on? And I think that since this is a politically, publicly funded project that works through the political process, we have an obligation to convince the shareholders, which are the citizens of this and other countries, that human spaceflight is important. And the way to do that is through inspiration. So again, with the shuttle retiring, with this need for sort of immediate feedback, what I sort of hope for in the next decade is, with all the science that we're doing up there, it would be really nice to have one of those aha moments. We are frequently asked, what is the greatest scientific contribution that you have learned on space station? And frankly, I think that answer to date can leave some people flat because it sort of doesn't affect them. What's in it for me is a very often asked question. If we can come up with something, a discovery, either looking outside or looking inside the human bodies, or some kind of technology demonstration that really gives us a leg up, and we don't have to wait the 20 or 30 years that it took to reap the benefits from the Apollo program, although they were technological, maybe more than scientific. I think that would go a long way toward securing the the public interest through the political process, and also the education. The kids that John mentioned of being inspired after the retirement of the shuttle, which I think is a challenge that we're going to have to face.
I think spaceflight is a hostile and unforgiving environment for humanity. It's really hard to live and work in, and this is a good test bed to evolve systems, to be able to keep thermal systems going for 10 years, and to be able to keep closed the loop on the environmental systems, and be able to be as efficient and learn as much as you can as that test bed provides is really an outstanding purpose for the space station. And I think that evolving those systems for the next big adventure is going to be the key.
I have one more thing to add. I think that the station as a symbol, and over the next 10 years, when I first came here, one of the first projects we worked on as young engineers was something called the operational control zones concept. And the idea back at that time was that we'd have a station flying around the Earth. We'd have a lot of other vehicles flying around it. We'd have to keep them in basic zones, like air traffic control. And with all you've heard lately with commercialization and all those sort of things, I would like to see in the next 10 years other vehicles coming to visit us, perhaps other vehicles up there, because I think, in my mind, as symbolic as the station is that can be that beginning of that hub, that allows other things to happen that are not necessarily within the government's control, but it inspires everywhere. It creates excitement throughout the world of people who may get the shot to see what we got to see when we looked out the window. So maybe in the next 10 years we'll have a little bit more of that.
Well, I want to give folks here in the audience an opportunity to come up to one of the microphones here and ask questions. So please do that.
Hi, I'm Roger Weiss. I've worked for SAIC. I've been with the ISS payloads office here since about the year 2000, just a little bit after Mike was head of the office. And it's been nothing short of a privilege to grow up with ISS and see it fully assembled and watch research sustain itself and diversify and even be maximized during some of our shuttle downtime. So, and now getting into national lab, more related research. So I really appreciate all your comments today. It's just great to hear these recollections. Some I knew, some I didn't. Since we're commemorating and acknowledging human habitation, I've always been curious about this question of the duration of the increments or expeditions, if you will, and how you all feel if that's been, even though we've gone 10 years, it's been obviously broken apart by many crew members. But do you feel that's been an appropriate amount of time get the work done, and of course, notwithstanding missing your families and hamburgers and pizza and beer and the ocean and whatnot, but is it enough time to have gotten the research done to get the right analogs and data that you need to be a true stepping stone to long duration space flight and exploration, or maybe longer? I'm curious as to what the managers and crew have to say about that. Thank you.
I think from my perspective, time is a little bit different on the station. On my first flight, first time up there, really excited to be there. The 6 months flew by, felt like about 2.5. On my second flight, we were really busy. We had lots going on. It was a phenomenal flight, really exciting. But 6 months felt like 6 months. So I think at some point, the first time thing will wear off. And, the time in space is a factor. I think on the space station, the challenges that we face are going to be different as compared to some of the exploration that we'll do in the future. Being able to see the Earth, being able to communicate easily with your families makes a huge difference in being up there. I think 6 months isn't too long when you have that kind of communication. It's going to definitely be more of a challenge from a psychological perspective to handle a mission away from the Earth. It's not something I don't think we can overcome. It's just something that I think we'll have to anticipate and look forward to. I think we should assign all rookies on that first one.
I would say there's another aspect to this, and that is just the time that you have to conduct all the operations. And we've been trying over the last year and a half, as you know, to focus more on the research and say, research guys get this much time, and everybody else is just going to have to now fit inside their box, whereas not long ago, it was, research got what was left. But what you find when you look at this whole crew rotation idea is that every rotation costs you time as well. Every extra flight that comes to space station takes a significant amount of crew time to prep for. The pre-pack, the post-pack, once a crew gets there, they have to get acclimated, so we reduce the amount of their workload early on. We have the safety briefings, we have all these things that take place, and they take away from time. And then, in fact, Peggy's mentioned this to me before, you get to a point as a crew member where you get really efficient on orbit. And it takes a couple of months, something like that. So after the first couple of months, you get really efficient. So as a program manager, what I prefer to do is not rotate the crews every 2 or 3 months, because then they never really get to the point where they're really efficient. Space station is very big. In spite of what we do with try to have all of our stowage laid out and identified where it is, we're always searching for items, and that takes much more time than you can imagine. And so there's this balance between so long that the crews become inefficient because they're missing home and all these kinds of things, and flying them so often that they never reach a point where they can be more efficient, and you're saving this significant time, about 100 hours of crew time for a rotation to occur. And so this is the balance you do as a program manager through all this. So today we do 6-month rotations, and it seems about right. And there's been a lot of questions about the future and what we're going to do. But I would tell you today we kind of got into 6 months because this is what our Russian colleagues have done, and we were flying with our Russian colleagues on the Soyuz. And my personal opinion is it's been a pretty good balance, and we'll always be looking at it, but it seems like a pretty good balance.
You were talking about doing a year at one point, weren't you?
Well, I still think for exploration, eventually it'll take time. Perhaps we should have crews on ISS as long as a transit might take, if we believe that makes sense, in order just to see what are we going to trip over anything in 9 months of hanging out in a tin can, or is it not remarkable past 6 months? And I think it'll have a lot to do with, and it'll be part of what we'll try to test, is your ability to communicate back home. The closer you get to Mars, the longer each communication takes. There won't be the same interactions we have today. And we need to test all of that to see, A, is there things we can do about it, and B, what's the mitigation if you just have to live with it.
Mike, I guess you get the last word because we are out of time. I'm sorry. So I want to thank everybody in the audience for coming and everybody on NASA television for watching today. The next event in our series of events today will be a recording of a discussion similar to this one that occurred at Marshall Space Flight Center in Alabama on Monday. And then at 3:30 p.m. Eastern Time, we'll go to our final live roundtable discussion from NASA headquarters with an all-star panel there. Thanks again for coming, and happy anniversary, International Space Station.